portable antenna group. So the motivation for this project was to create a rotator for a radio antenna that can be used to track satellites or be pointed at ground targets. We are doing this project for the Arctic Amateur Radio Club.
Current solutions that solve this problem tend to be expensive, heavy and bulky, and often struggle in extreme environments. Being in Fairbanks, our mentors wanted this to function at 20 below Fahrenheit, all the way up to 100 plus. It's supposed to remain cost competitive with current off-the-shelf options, which tend to be very expensive, so that bar is actually not that hard to hit. It's designed to be lightweight and portable, so that you could take it on a hike up to a remote place where you're not necessarily going to have access to a vehicle.
It must use GPS to track satellites or ground targets, and it should be able to self-orient to true north.
The initial design started as a lot of conceptual sketches and drawings. Once the major mechanisms were determined, we decided to create a 3D printed prototype to test the fit and function of all the major components. All these components underwent several iterations before landing on the final product, at which point we decided to start manufacturing with actual materials. Stainless steel key stock was used to manufacture the bearing blocks, while the sheet metal parts were made out of 2 different alloys of aluminum. We chose a more cost-effective and corrosion-resistant alloy called 6061 aluminum for most of the components, and we used a higher strength, higher hardness alloy called 7075 for the gears and other critical stress elements.
So going forward, we're going to want to give this antenna to our mentors who are going to do some field testing with it. So hopefully we can find some improvements we can make in the future. And we're also going to leave all the files open source so that others can manufacture this on their own.